When dealing with legacy systems like the Siemens S5 S5 441 8Ma10 digital output board, encountering a blown fuse can halt operations entirely. The Bell MQ10A fuse, a crucial component for protecting the board, has failed. This isn't just a minor hiccup, it's a significant interruption that demands immediate attention. Understanding why this fuse blew and how to properly replace it is critical for maintaining system functionality. The choice between a fast-acting and a slow-blow fuse can make a difference in how your system responds to overloads. Fast-acting fuses are designed to blow quickly in response to a surge, protecting sensitive components but potentially causing unnecessary interruptions. On the other hand, slow-blow fuses allow for temporary overloads, which can be beneficial in certain applications but might not offer the same level of protection. Choosing the right type of fuse is not just about replacing a part, it's about ensuring the longevity and reliability of your entire system. And here's why that matters. Fast-acting fuses, also known as quick-blow fuses, are designed to respond immediately to overcurrent conditions. They are ideal for protecting sensitive electronic circuits where rapid response is critical. On the other hand, slow-blow fuses, or time-delay fuses, are engineered to allow a temporary surge in current before they blow. This makes them suitable for applications where inrush currents are common, such as motors or transformers. Understanding these differences is crucial for selecting the right fuse for your specific application. Imagine a scenario where a motor starts, a fast-acting fuse might blow unnecessarily during the startup surge, whereas a slow-blow fuse would tolerate this temporary high current and protect the circuit during continuous operation. Understanding the fuse requirements for the Siemens S5 boards is crucial for maintaining the integrity of your system. The Bell MQ10A fuse, which you're looking to replace, is a fast-acting fuse. This type of fuse is designed to break the circuit almost instantaneously when a fault occurs, which is ideal for protecting sensitive electronic components. In contrast, a slow-blow fuse allows a temporary overload before it trips, which might not be suitable for the delicate nature of the S5 board. To ensure optimal protection, it's recommended to use a fast-acting fuse with the same amperage rating as the original. This will safeguard your board against sudden surges that could otherwise damage the circuitry. Remember, the exact type and rating of the fuse are specified in the board's documentation, which should be your go-to reference for any replacements. Now, let's dive into the practical steps for replacing the fuse on your Siemens S5 S5 441 8Ma10 digital output board. First, ensure the system is powered down to avoid any electrical hazards. Locate the blown fuse, which in this case is a Bell MQ10A. Carefully remove the old fuse using a pair of non-conductive tweezers. Next, you'll need to choose the correct replacement fuse. Given the nature of the application, a fast-acting fuse is recommended over a slow-blow type to ensure immediate protection. Insert the new fast-acting 10A fuse into the socket, making sure it's securely in place. Finally, power up the system and test the outputs to confirm everything is functioning correctly. Remember, safety first, always wear appropriate protective gear when working with electrical components. One frequent error is substituting a fuse without considering its speed rating. If you replace a fast-acting fuse with a slow-blow type, you risk prolonged exposure to overcurrent conditions, potentially damaging the circuit. Always match the speed rating of the replacement fuse to the original. Another mistake is overlooking the current rating. Using a fuse with a higher rating than necessary might not protect the circuit adequately, while a lower rating could lead to unnecessary interruptions. Ensure the replacement fuse has the exact current rating as the original. Additionally, some technicians fail to verify the voltage rating, which is equally critical. A mismatch here can result in the fuse either failing to operate or operating under incorrect conditions. To avoid these pitfalls, always double-check the fuse's speed, current, and voltage ratings before making a replacement. Let's bring everything together for optimal fuse protection. First, remember the difference between fast-acting and slow-blow fuses. Fast-acting fuses are ideal for circuits requiring immediate protection against high current surges, whereas slow-blow fuses are better suited for applications where temporary overloads are common. For your Siemens S5 digital output board, A fast-acting fuse is recommended to protect against sudden current spikes that could damage the board. Next, always verify the amperage rating matches the circuit's requirements, in your case, a 10A fuse. Lastly, consider the environment. If the board operates in a high vibration setting, a fuse with a higher interrupting rating might be necessary to ensure reliable performance. By following these guidelines, you ensure robust protection for your equipment. And if you found this deep dive valuable, consider subscribing for more free, high-end technical education.